Hi guys, so today we are going to be solving the parts of the ellipse given its general equation. Now in this video, we will be solving the parts of the ellipse whose center is at the origin, followed by an ellipse whose center is at point HK. Also, I will solve the parts of the ellipse whose major axis is horizontal and vertical. So all in all, we will be solving four problems regarding the parts of the ellipse. Let's start with the first problem. We have here the general equation of the ellipse. 25x squared plus 9y squared equals 225. Now, to identify the parts of this ellipse, I would have to divide 25x squared plus 9y squared equals 225 by 225. So, I would have here 25x squared plus 9y squared equals 225. I will have to divide both sides by 225. Simplifying, I would have the equation here 25x squared over 225 plus 9y squared over 225 equals 225 divided by 225. Simplifying the fractions, the standard equation here would be x squared over 9 plus y squared over 25 equals 1. We now have the standard equation. And the next step here is to solve for the length of the semi-major and semi-minor axis by comparing these two denominators. So always remember, the square of the semi-major axis is always the larger denominator. And since 25 is greater than 9, our a squared here, or square of our semi-major axis, would be equal to 25. Now to solve for the semi-major axis, just take the square root on both sides. Therefore, a would be equal to 5. And as for the semi-minor axis, I would equate b squared to 9. And solving for b, so I would have b here equal to 3. So now that we have these two values, the next thing to do here is to identify the orientation of the major axis. And since our a squared is located on the term containing y squared, its major axis is vertical. And since our major axis is vertical, we would have this following coordinates as well as this equation. So let's now solve the parts of the ellipse. I will start with letter A, coordinate of the center. So for this general equation, it is the general equation of the ellipse whose center is at the origin. Therefore, the coordinates of the center would be 0, 0. Next, for the length of the major axis, that would be 2a. We've already solved the value of a, and that is 5. So the length of the major axis here would be equal to 10. As for the length of the minor axis, which is 2b, I would substitute the value b, that is 3. Therefore, the length of the minor axis will be equal to 6. Then for letter D, coordinate of the vertices, just follow the coordinates here. So I already solved the value of a. Therefore, the coordinate of the vertices would be 0, 5 and 0, -5. So we just plug in the value of a in this coordinate. Now for the coordinate of the vertices, we have b0 and -b0. Plugging in the value of b, I would have here the coordinate 3, 0 and -3, 0. Now for the coordinates of the foci, before we can solve for these two coordinates, let's solve first for the value of c, which is the distance from the center to one of the foci of the ellipse. So the equation here is the square root of a squared minus b squared. Plugging in the values, I would have the square root of 25 minus 9. So that would be the square root of 16. Square root of 16 is 4. Therefore, c would be equal to 4. So we can now identify the coordinates. So I would have here 0, 4 and 0, negative 4. Next, for the eccentricity of the ellipse, we have here the equation c over a. C is 4 divided by the value of a, that is 5. Therefore, the eccentricity here would be 0.80. For the latus rectum, the formula is 2b squared over a. So, plugging in the value of b and a, I would have here 2 times 3 squared over 5. So, this would be equal to 2 times 9, that is 18. 18 over 5. In decimal form, that would be 3.60. Next, for the equation of the directrices, let's solve first for the value of d, which is the distance from the center to one of the directrices. So the equation for this one would be a over e. Plugging in the value of a, that is 5. The value of the eccentricity is 0.8. The value of d would be equal to 6.25. Therefore, the equation of the directrices here would be, the first one is positive 6.25, and the second one would be negative 6.25. Now, for the last part, we have here the endpoints of the Latera recta. So, take note here, we have b squared over a, and b squared over a is just half of the latus rectum. Since we have here 3.6 as the latus rectum, its half would be 1.8. Therefore, its coordinates would be, the coordinates of the endpoints would be, the first one is b squared over a, that is 1.8. C is 4. And this one here is negative b squared over a, that would be negative 1.84. Next pair of endpoint here, so this is 1.8, then negative c, that is negative 4, and negative 1.8, negative 4. So these are the endpoints of the Latera recta. Now, if you try to graph the parts of the ellipse, so we would have this figure below. We have here the center at the origin, the endpoints of our major axis, which is the vertices 0, 5, 0, negative 5, endpoints of our minor axis, which is our co-vertices, negative 3, 0, positive 3, 0. The coordinates of the foci is 0, 4, 0, negative 4. And the four endpoints of our Latera recta, we have here 1, 2, 3, 4. And last is our equations for the directrices. So the first one here is y equals 6.25, represented by this horizontal dashed line. The second one here is y equals negative 6.25, represented by this horizontal dashed line. Let's now proceed with the second problem, wherein we have an ellipse whose center is still at the origin, but this time the major axis is horizontal. So for the second problem, we have here the general equation 4x squared plus 16y squared equals 64. And to solve for its standard form, we would do the same process we've done on the previous problem. So I would have here 4x squared plus 16y squared equals 64. Then I would need to divide both sides by 64 to make the right side of the equation equal to 1. So I would have here 4x squared over 64 plus 16y squared over 64 equals 64 over 64. Simplifying, I would have here x squared over 16 plus y squared over 4 equals 1. So this would be the standard equation of the ellipse. Next is for the length of the semi-major and the semi-minor axis. Now remember guys, the larger denominator, which is 16, is always equal to the square of the semi-major axis. So I would equate a squared here with 16. Solving for a, so the semi-major axis here would be equal to 4. As for the semi-minor axis, I would equate b squared to 4. And solving for b, mu here would be equal to 2. Then, as I mentioned a while ago, the major axis of this ellipse is horizontal. So the reason to that is our a squared is located on the term containing x squared. So if that's the case, we would use here the following coordinates to solve for its parts. So this coordinates here, and this equation is different from the coordination equations from the previous problem. So let's start with the first part, the coordinates of the center. Still, this is an equation of an ellipse whose center is at the origin. Therefore, the coordinates of the center is still 0, 0. Next, for the length of the major axis, 2a. Substituting the value of a, which is 4, I would have here the length of the major axis, which is equal to 8. For the length of the minor axis, this is 2b. That this would be 2 times 2. The length of the minor axis here would be equal to 4. As for the coordinate of the vertices, using the value of a, I would have here 4, 0 and negative 4, 0. Also, the coordinate of the vertices is also called the endpoints of the major axis. For letter E, coordinate of the co-vertices, this would be the endpoint of our minor axis. So we would use here the value of b, and the coordinates would be equal to 0, 2 and 0, negative 2. For the coordinates of the foci, let's solve for C. So we would use the same equation we've used in the previous problem, that is square root of a squared minus b squared. So plugging in the value of a squared and b squared, I would have here square root of 16 minus 4, that is square root of 12. If I convert that one into decimal form, square root of 12 would be equal to 3.46. So rounded off to 2 decimal places. So now that we have the value of C, the coordinates of the foci here would be 3.460 and negative 3.460. Next, for the eccentricity of the ellipse, the equation is still C over A. C is now 3.46, A is 4, so the value of this one would be 0.87. 0.87 rounded off to 2 decimal places. For the length of the latus rectum, this is still 2b squared over a. Solving for the value, so substituting the value b, that is 2 squared, then over 4. So 2 squared and 4 cancels out. Therefore, the length of the latus rectum would be equal to 2. As for the equation of the directrices, let's solve for d. This is equivalent to a over e. So a is 4 divided by the value of e, 0.87. So the answer to this one would be 4.60, rounded off to 2 decimal places. Therefore, the equation of the equation of the directrices here would be, the first one is positive 4.60, and the second one would be negative 4.60. Now, for the last part, endpoints of the Latera recta, again, we would have to use here the value of b squared over a, or that is just half of the length of the latus rectum. Since the length of the latus rectum is 2, its half would be equal to 1. So every coordinate here, which is equal to b squared over a, is equal to 1. So I would have here the coordinates c b squared over a, that would be c is 3.46, 1, and 3.46, this time this is negative 1. For the second pair of endpoint, we have here negative 3.46, 1. And for the last point, negative 3.46, negative 1. So these are the endpoints of the Latera recta. Now, if we try to graph the parts of the ellipse, we would have here this figure. So the ellipse here is centered at the origin. We have here the endpoints of our major axis, which are our vertices, 4, 0, negative 4, 0. Endpoints of our minor axis, which is the co-vertices, 0, 2, 0, negative 2. Coordinates of our foci, 3.460, negative 3.460. Endpoints of our Latera recta, we have here 1, 2, 3, 4. And last one would be the equations for our directrices. So we have here x equals, this one here is positive 4.60. On the left side, this one here is x equals negative 4.60.